Okay, so we're going to wrap up our Python tutorial with a kind of in-depth construction of a data structure called a linked list. Um, and we'll go over all the remaining facets of Python as we make this. So let's just get started. So we're going to make a data structure called a linked list. If you don't know what a linked list is, just kind of think of it as a different way of kind of storing items like a list does, but we're going to define it to our own pleasing. So a goal of this data structure is to use magic methods to make it seem like you're using a list even when you're not in Python. So like, let's just set x equals 1, 2, 3. We have x. When you type in x, it prints out this nice bracket, all the numbers inside. We can index it. We can take the len, etc. There are more things we can do with it, but these are the things that we're going to try and replicate when we're doing this activity, including append, just because they're simple and they'll let us kind of practice our data structure building in Python. So we're going to create a data structure called a linked list. The first thing we'll do is we'll create a class called a link, and this will store all the data for our linked list to use. So this will be very simple. Def init self x next equals none. We'll call that nxt. So a link will just store an item and a variable called next, which will be the next item in the link. So it's almost like a chain. That's kind of why it's called a linked list. So a linked list is just made up of a big link that contains links to other links. You'll see what I mean. So we'll do self.item and create an item attribute. X self.next equals nxt. So this nxt variable is either supposed to be none, which we pass in as a default argument, or it's supposed to be another link. So to ensure that our users don't pass in something they're not allowed to, we'll create something called an assert statement. Essentially how an assert statement works is it takes in a Boolean condition and an optional error message, and if the Boolean condition evaluates to false, it'll throw an error. Throwing errors is important so that people know that they can't use your object in a particular way, and just makes it easier for them to not make mistakes. It's counterintuitive as throwing an error sounds. So we'll assert that the type of next equals blank. So equals is the way that you check for equality, or nxt is none. Is checks if this variable here points to the same location in memory as none. So if it's none, it will. If you want to check for equality, you'd have to do equals. This part right here is typically done in a function called isInstanced, and we'll type in next link. That accomplishes the same thing in less code. All you have to concern yourself here with here is that if the user were to pass in an item that's not a link, they'd get an error. And if we add in a comma and a quote, we can give them a nice message like next must be of type link or none. Okay, now let's make our linked list. Okay, so what's this variable x going to be? Well, we'll make it a default to none. And if you remember in Python, there's a list function that either creates an empty list or converts an iterable type like a tuple into a list. So that's what our x will be. It'll either be nothing or it'll be an iterable type. Okay. So, let's first check if x is none. That'll be simple. If x is none, well, that means we have nothing to pass in, and we'll create a variable called self.data. And we'll set that to none. Or actually, you know what? Let's create the variable to none no matter what. And if x is none, we'll just do nothing. Okay, so for now I'm just going to put in a pass. I'm going to actually delete this statement later because we don't need it, as you'll see. So I'm just going to create another if statement for if x is not none. So not works in a funny way. So you could do either is not, which is kind of like the standard English way, or another way is not x is none. Will be the same thing. So if x is not none, what are we going to do? Well, we have to add everything in x into self.data. So we're going to assume here that x is iterable. There's a way to check for it, but we're not going to go that in depth into Python because that's just some advanced stuff. So we'll just assume that it's iterable. If it's not, an error will be thrown anyway. It won't have as much of a useful error message, but whatever. So we'll do for I in x, self.data equals link of I, self.data. So if you remember how this link works, it takes in an item value and a next value. Self.data always starts out as none, and if we pass in an iterable, it'll keep taking elements from the iterable and kind of making the link longer, inserting those values in as the values, item attributes of our link object. So you'll see what I mean when we're printing this out. It'll make a little bit more sense. We can delete this. Let's also create a variable called self.length. Set that to 0 to start with, and we will also increment it by 1. As we add items in. So this length will keep track of the length of our list, which can be very useful. So now let's say we want to replicate the len feature of lists. So we could do def _ len self, and we'll simply return self dot. Okay. So this is a magic method, as is init, and as are the rest of the methods we'll be creating, some of them at least. This will let you use the Python len function on your data. So just to do a quick demo so far, we'll do Python 3, and the way that you import a module or a file is you can just simply type in import. This is called linked list .py. Yeah, you don't need the .py. I forgot about that. So let's create y equals linked list, and we'll type in 1, 2, 3 as our numbers. Oops. Alright, well, let's just start by making it. Oh, I'm sorry, I see what I did. So since we just imported linked list, we would need to do linked list dot linked list. I'm just going to make this easier for us. From linked list, this is the .py file, import star. So now we have access to all the methods in there, and we can make a new linked list called y. We can do y.length, we're expecting 3. We get it. Len of y, it's also 3. So, after you define y, you can do this len method and almost feel like y is a list, right? Let's make some more useful methods. So, that defines the len. What about adding to our list? So, in list is called append, so we'll just do append. Make a nice doc string here. Adds item x to the linked list. Okay, now before we go any further, I just want to let you know that we're kind of simplifying this a little bit. So we're trying to make it behave like a list, but we're not going to go into any of the super complex methods just yet. So when we create our list from an iterable or when we append to it, we're going to kind of do it backwards. So a list adds to the back of itself. We're going to add to the front of the linked list just to make it a little easier based on how we have our link items defined. So when we append x to our list, we will simply do self.data equals link of x comma self.data. Right? And we have to increment the length variable, which we do as so. Okay, so now we can append to it. Before we test this out, let's make a nice repr method, just so that we can print out our list and see everything that's inside. So now what you're going to see is some useful string operations in Python. So in Python you can add strings, like you could do h plus I, and that'll give you hi. It'll concatenate them. And I could also do it'll give us hi there. And even though I'm using double quotes on these two and single quotes on this, it doesn't matter. So this method has to return a string. To get the repr of our linked list, what we'll do is we'll kind of make it like the list one. So we'll start out with just a bracket, and we'll call that our string. And then what we're going to do is create a dummy variable called, we'll just call it copy, and we'll let that equal self.data. And then we'll do while copy is not none, because the last item in the list will be none, since we're just kind of pushing items on top of that none. And then we'll do string plus equals str of copy.item, so that converts it to a string, plus with a comma after. Okay, so on the last item in the list, this will also put a comma space after. Once again, we're just kind of running through this quickly, so we're not going to handle for that right now. And then, okay, so the string will be constructed like that, and then we'll do string plus equals closing bracket, just close it, and we'll return string. Okay. So now we're going to exit out of Python quickly. You can also import a package in the same way as we did from linked list imported star, by when you're starting Python, do python 3-i linked list.py. So that imports our linked list file into here. So let's create y equals linked list y, and there we go. We get empty brackets. Y dot append 6 y, and You must have entered some kind of an infinite loop. Okay, I see what I did here. So what we forgot to do is move copy along. So we'll do copy equals copy dot next. Okay, sorry about that. So we'll exit out of Python, do that same thing again. Y dot append 6, Y, and we get that list. We can keep appending numbers to it, and it behaves kind of like a list. Once again, we didn't account for this last element, so if we really wanted to, this is a good place to show string splicing anyway, we could do string equals string up to -2. And try that out for size. Yep. So that got rid of everything in the back. There we go. So as you can see, it adds to the front of the list. Let's do something like for I in range 10, y dot append I. And there you go. You got the range of 10 put in backwards into I because it continually inserts into the front. Okay. So I owe you a bit of an explanation for this string splice, so I'll show you how that works. You can take a string or a list or some kind of an iterable and create a copy of it using that kind of a string splice. So you could do hi 0, it'll give you the letter H. To make this hello, same thing. If you do 0 colon 3, that'll give you the first 3. You could also take out the 0 and the default argument is 0. So there you go. 0, 4. You could do 0, 5, 0, 4, 2, and that'll give you every other one. Oh, 2 brackets. Yep. So go H, skip the E, L, and then it won't go any further. So we'll increment by 2. You could also just do it to the end like that, or like that. So in this case, if we were to do the same thing we did to the other one, like that, we'll get everything except for the last 2 characters because we're splicing it up to this L, this second L. So that's what we did there. There's easier ways of doing it that don't involve iterating through the string again and creating a copy. But once again, we're going for simplicity here. Okay. Another thing you can do with a list, let's see. Oh, you can take indexes of it. So if we go like x is just a regular list, x of 0 will give us a value. So let's create a magic method again called getItem. This is how we can do. This is how we can take out an index of the list and get that. So there's 2 cases to worry about here. Let's worry about the easier one first. So let's assume I is a positive number. First, what we have to do is make sure that I is within the bounds of our list. So if we go for a number like 27 and our list has 2 items, we should get an error. So we'll go assert, and we'll go I is less than self.length. And then we'll go index is out of bounds. Okay, so if somebody puts in a number that's too big, they'll get an error. Now what do we do? Okay, so we'll do something similar as we did in repr. We'll create copy equals self.data, and we'll use a while loop again, the same one. Copy it over for simplicity. Take out the string part. Okay. So actually, we just need to get copy to the right place. So instead of this, actually, we'll go while I is greater than 0, and we'll go I minus equals 1. So this will iterate through all the contents of the list the number of times we need, and then what we're going to do is we're going to return copy.item. Okay, so that's one simple case. What about when there's negative numbers? So if we do x of -1, we'll get 3, the last item. As I had mentioned before, the formula for the negative numbers is simply the length of the list plus that negative number. So just to make it very simple on us here, we're going to add in a condition. If I is less than 0, I plus equals self.length. So that converts into a positive number, presumably. And then it goes down to this if condition. We'll add to this assert statement just to take into consideration the case where I is too negative of a number, meaning too small and still more than the length. So we'll also assert I greater than 0 and I equals, yeah. So now it'll work just like the list slicing methods. So let's run that again. Y equals list. Actually, let's just make it a range of 10. So now we have y equals a range of 10 backwards. What's the first element? Oh, has to be greater than or equal to 0. Okay, we'll just do the first one for now. So we know that's 8. What's the fourth index? It's 5, right? 0, 1, 2, 3, 4. Correct. What about the -1? 0, -2, 1. So we have this working list index. I had to change the assertion statement a little bit around, but this is what the error looks like for an assert statement, assertion index, and our message. So, yeah, we have a pretty well working linked list class. If we do print of y, it'll automatically give us a repr, which is this nice list. And it's almost gotten to the point where we can't tell that we're using a linked list anymore, can we? We're using all the same methods as the list, we're indexing. I guess one potential other thing is setting items. So if we have a list, we have our list. Oh, we didn't define our list x in this one. If we do x of 0 equals 7, we changed the 0th value of x to 7. With our current one, if we do y of 1 equals 9, it doesn't support item assignment. We didn't define a set item method. In the code, we could have written a method called __ set item that allows us to do that, but we're not going to do that right now. Okay, well, we have this nice linked list class in less than 50 lines of code. We were able to somewhat replicate the behavior of the list. Um, there are other ways of making sure that the data, for example, stays in order and that the append goes to the end of the list and things like that. But this is a good place to stop our little introduction. So yeah, I hope you guys got a lot out of this video.